Hey guys, and welcome to the new part of the uFrame tutorial. This one is number 6, and if you remember, in the previous part I was left with my scene completely reverted to its initial state cause Unity crashed. Maybe Unity just didn't like my art, cause you know I'm a bad designer, so I've decided to draw a few more figures, and there we go with a completely new setup, which is still bad as to me, but at least we have something to look at. Today we're going to fix a couple of things from the previous part and also apply effects to our scene and make stuff more fancy. And maybe we will manage to do the GUI. So first let's learn how we can diagnose issues with the collections and see if the problem is on the controller side or on the view side. What we currently have is our Pinky Aliens game right here, which generates enemies for us. And if we put two equal numbers here in the rows and columns and generate those, we can see that indeed we got 16 enemies, and here we got this number. This number right here corresponds to the amount of enemies in the collection in the actual view model. But you can still have some badly generated views or no views generated. So this is where you can see if your problem is on the controller side or on the view side. If we put 5 here and generate enemies again, we can see that in the collection we got 20 enemies, but on the screen we see only 4 by 4 of those, which is 16, I guess. Now we know that our problem is on the view side. So our next step is to see how many enemy views actually get generated. But how do we keep tracking of those? If you look at this base invocation of the enemies added binding, you can see that the base stuff just adds the newly generated view to the enemies list, which represents all the enemy views which are currently in this Pinky Aliens game view. So this is a convenient way of keep tracking of those, and we can use this one. We're going to override on GUI method and generate a simple label using GUI layout, which will tell us how many enemy views we currently have in the scene, or at least how many enemy views we actually have in this enemy list container in this particular view. If we hit play and place something like 5 by 6 and start the game, we can see that we got 30 enemies in the collection, and we got 30 enemy views generated, which means that we actually got all the views generated, but the placement seems to be incorrect. Our placement is performed using this code right here, and obviously these modular rows causes the problem because it should be modular columns. Now if we hit play, we can do 5 by 6, we can do 3 by 4, we can do 4 by 2, and pretty much everything works as expected. Now we are ready to start doing effects and some fancy stuff. I'm going to utilize sort of one-shot particle systems a lot, and I'm not going to think much about such things as pooling and reusability, because I don't want to waste time for this. But in your real-life project you should probably implement those. So there we go. I got a few prefabs for the enemy explosion and rocket explosion, and again those are ugly because I'm a bad designer. Actually I started using the Adobe Illustrator a week ago, so well, at least we have something to look at. And I also got a few animations for the enemy which correspond to his lose of control, you know, before he actually explodes. All of those are 1 second length, which will help us to time things a bit. And I also added this rocket launch prefab right now, just so we have something to happen when the rocket actually starts. So let's see how we can apply those using entry points which uFrame gives us. And we will start with the enemy guy. So let's navigate to the enemy view and create a few settings here. This one will be our enemy explosion prefab. And in our play death method, we can do this after we execute died. Though probably it's not the best case, but let's do it here before we actually die. Oops. We will instantiate the game object. And set its position to the position of the enemy, and rotation to known. And we also want to destroy this game object after something about 2 seconds. So let's see if it works. So we can see that on our enemy view we got this little setting generated for the prefab. So let me remove this redundant stuff from the scene and set the enemy explosion to the prefab we got and apply these settings. So now we go and generate a few enemies. We can fire them and they explode. Which doesn't look that much good, but it's working, so let's get to our bullet really quick. So we got this little rocket script, and there we go. We got this rocket destruction here. So let's create a setting as well. Explosion. And instantiate this. The position should be equal to transform position, and the rotation, we shall set this to identity here, but right here we will take the transform oh yeah, you should always cast those, but right here we will take the transform and set its up vector to minus this dot transform dot up vector. So this will kinda flip our explosion, and you will see that it will look much more natural. Well, yeah, it will. Actually, let me do forward this up. I'm not entirely sure yet, but we'll test it right now. And we will destroy this explosion in about 2 seconds as well. Let me get my rocket prefab from the resources. Also, let's grab those guys and put those into resources as well. And on our bullet, we got a rocket explosion. We can apply this one and see what happens. Yay! So we can generate enemies. Well, it still needs some tweaking. But yeah, Rocket is not really part of uFrame, so let's go ahead and apply this rocket launch sort of explosion. Let's go to platform view and again create the setting called rocket launch effect. And now you see why this launch rocket method is actually useful. We can separate all the stuff related to effects and rocket launching in this one. So we launch the rocket, and here we will instantiate the effect. Set position to transform or gun point transform position, and rotation to identity. Cast this to game object. We will destroy this effect again after 2 seconds, I guess. And also, let me take my platform base. I don't remember if I actually created this property in the tutorial, but this where is it? Oh, there we go. This public property right here corresponds to the rigid body of my platform base. And we will use this right now. What we will do is we will add force we will take our gun point and its up vector, then we will revert it and multiply this by something big, something very big, I guess. Oops. So yeah, I should assign my platform base, and also I should assign the effect rocket launch. Apply this just in case. So now you see that we actually got some fancy effects, and our platform leans back a bit, which is exactly a result of what we did here. We took the gun point and its direction, which represented with this green arrow, and we flipped this one and applied the force in this direction. And notice that this enemy will not get destroyed because it's not controlled with the corresponding Pinky Alliance game, and his view will never get destroyed, though his state will be set to dead. Now it's time to make use of our enemy animations. I got this animator on my enemy, which has 3 states. And notice that I got this little typo right here, NMT instead of enemy. The other thing to mention here is that we got this animation as a default state, which is incorrect because we want our enemy to be clear of animations when we start. So I will create a new state and make this to be default. And also notice that those animations control the enemy sprite right here and not the enemy object itself. which will be important in a second. So let's go to our enemy view and let me apply some dark magic. And as you can see, I got cache variables for animator, collider, and sprite, and I cache those in the start method. Also notice that sprite is taken from the child. Now we're going to modify this play death coroutine, where we basically wait for one frame to make our trigger events to work along with the rocket, and then we declared our guy dead, so the view of the enemy was destroyed immediately from the Pinky Aliens game. But now we're going to modify this behavior, and the first thing we want to do is we also want to wait for 1 second. This is because all of my death animations take exactly 1 second to play. Now here I want to take my animator and play the state called NMT due to typo, lost control, and then I want a random number. I will take it using enemy engine dot random dot range. And notice this last number is exclusive, so I will get 1, 2, and 3 as my possible values. Also, since our enemy is not kinda alive anymore, I want my collider to be disabled. But again, I have to wait 1 frame before doing this, so the trigger events will work. Let's test this. So I will create enemies and start killing those. But as you can see, we got a little problem because the explosion is not instantiated in the right place. This is because here, when instantiating the explosion, I want to use the transform of my sprite, because the sprite actually changes the position and not the enemy. Perfect. So now when we got working prototype with a few effects, it's time for us to make some GUI. And also it's time for us to learn view components, which are very useful. What is a view component? Well, just to start with, this is the guy which you can create in your element diagram and give it some sensible name, like Pinky Aliens Game GUI. But in the global scope, view component is something that helps your views to become composite. Sometimes you just want to separate GUI stuff from the rest of the view, and again you have two options. You can either define two views for a single view model, and you know, when instantiating the view model and the view, you have to get your two views and bind those to a single view model, which is kinda an advanced setup and makes things complicated. But view components are kinda natural because they can exist in your view and be a part of it. And at the same time, they completely reflect the same functionality that you have in your view. To link the Pinky Aliens Game GUI view component, you hold Control key and drag the arrow to the element. And notice that we actually link the view component to the element and not to the view. This is because this one will be available for us in any view which we may declare. Let's hit save and compile and explore the generated code. So currently, I'm in the Views Designer file. And we got this Pinky Alliance game view base, which is the very basic class for all the Pinky Alliance game related views. And notice we got this little thingy here generated, called Pinky Alliance game GUI. And it has a property type. And basically, you got this little property right here. And here we see that if we have no Pinky Alliance game GUI assigned, then our view will try to search for this one in the same game object using the getComponent function and cache this one. But what is a view component and what is this type? In the same diagram, designer file, you have this type generated called Pinky Alliance game GUI, which extends ViewComponent, but the ViewComponent is just a mono behavior, and also it's a binding provider. So ViewComponent has a link to the view which this component belongs to, and also it has the appropriate property, and in awake method the binding happens. And in the bind method you can do whatever you want. Manually, of course. So basically, ViewComponent is the same as view, because you can bind to things, unbind of things. And also, if we get back to our concrete class called Pinky Alliance game GUI, you will see that we got execute start command and execute game over. So we got methods to execute commands. And we also got a link to the view model. The only difference between ViewComponent and the view is that ViewComponent belongs to the view and stores all the bindings created in this ViewComponent in the view, and when your view gets destroyed, the ViewComponent bindings are destroyed as well. I'm not sure about the ViewComponent itself yet, but we will see. So now we also got this partial class generated, where we can actually start doing some things. So first, let's see how we can set up Pinky Alliance game GUI and the Pinky Alliance game view so that they know about each other. We already know that when trying to search for the Pinky Alliance game GUI, Pinky Alliance game view base is trying to search the same game object if we haven't assigned anything in the inspector. And yeah, we got a setting in the inspector right here. So we can directly assign this before we actually start the scene. And of course we can assign it during the runtime. In the same time, when our ViewComponent starts and his awake method is called, it's trying to access the view property. And the view property, if not assigned, and yes, we can assign view for the Pinky Alliance game GUI right here. If this one is not assigned, then ViewComponent is trying to do the same as the view. It's trying to search for a view base in the same game object. So, one possible setup is that we just drop the Pinky Alliance game GUI on the same object as the Pinky Alliance game view. And at this point, they will know about each other, and everything will work as expected. The advanced setup allows you to separate the view from the ViewComponent and create another game object. Let's call this one Pinky Alliance game GUI and drop the Pinky Alliance game GUI here. And yeah, you can separate those. But notice though that on awake method, of the view component, the binding happens. So the view component will probably want to know about the view because it requires some information to assign the appropriate view model, for example. In Pinky Alien's game base class, or first part of the class, we got this property which requires view to be resolved. And if you don't assign the view to the Pinky Alien's game GUI, then it will have no idea of what he's working with. On the other hand, your view doesn't require you to assign any Pinky Alien's game GUI, but you want this in case you're going to control your Pinky Alien's game GUI from the original Pinky Alien's game view of any kind. So you can have a lot of Pinky Alien's game views, and some of them may refer to your Pinky Alien's game GUI component or view component. So in this case, you want them to know about this Pinky Alien's game GUI. So another setup is to know Pinky Alien's game GUI, to know about the view model, or I mean the view. Oops. And I can assign this directly from the scene. So at this point, all the bindings will work on Pinky Alien's game GUI, but the Pinky Alien's game view will have no idea what's going on with its Pinky Alien's game GUI component. And more advanced setup if you assign the Pinky Alien's GUI component to the view. So in this case, view will know about the component, and you can refer to this component without getting any null reference exceptions. So this should give you the basic understanding of how you can set up those, and when doing it runtime, of course you will want to assign their appropriate variables manually. So one possible approach is to create the view component when you actually create the view, and do it from the view. So you can, I don't know, you can be very creative about how you assign and create and replace the components. So now let's see what we can do about the components themselves. Since the view components are just mono behaviors, we can do any kind of stuff we do with the mono behaviors. So for example, we can override our favorite onGUI method and show a few variables from the Pinky Alien's game, because we have this property directly on the view component, so we can access Pinky Alien's game, but only in case that we have our view set up correctly. So let's do GUI layout label and name this one score. And this will show Pinky Alien's game score. Also, in my Pinky Alien's game controller, I modified my enemy state change a bit, and I add 100 points for each enemy killed, or for each enemy which is dead, to be more specific. Also, I can, for example, show stuff like how many enemies I have. And also, I can show more things, like for example, speed of my platform, which belongs to this Pinky Alien's game. And of course, I can create a button called start, and in case this one is clicked, I can execute start the game, which is kinda awesome. Let's see if it works. So I got all those variables here, And if I click start, I got all the enemies or amount of those enemies. And if I kill one, I get my score updated every time the enemy dies. And my current setup also allows me to access the Pinky Aliens game GUI from the view. So let's think of some kind use for it. So let's create a variable here. Public string Pinky Aliens game view message. And this one will be empty by default. And here I will add another GUI label called last message from view. And I will show this message. From my Pinky Aliens game view, I can, for example, show stuff like enemy added. So this is kind of stupid example of how you can access the Pinky Aliens game GUI and do something with it. Like, you can be very creative, you can define methods, actions, like everything. So it's totally awesome. So now we got this empty message, and when we hit start, we got this enemy added message. But notice that this became possible because my Pinky Aliens game view directly knows the Pinky Aliens game GUI. If I remove this link, I'm going to end up with a problem. A null reference exception. So pay attention to this. And of course, if you will have your Pinky Aliens game GUI in the same component or in the same game object, you will have no problems without even assigning any of those variables, neither on the view nor on the view component. In this example, I use the native Unity GUI system, or after Unite I should probably say old native Unity GUI system, which is kinda unique because, you know, you define stuff procedurally here, and that's why it invokes this onGUI method every time the GUI is drawn on the screen, and reads those values again and again and again, and that is why they are kept up to date on the screen. But in your real life projects, you are probably going to use some sort of a third-party GUI system, which will require you to set different parameters and properties of different UI components in order to keep the information up to date. Like, for example, text of the label, or, you know, text of the button. Basically, you usually set text and pictures. So let's see how we can utilize bindings on the Pinky Aliens game GUI view component to solve this kind of problem. First, let's define a new variable here called score, which will be int, and it will be 0 by default. Now let's make our label to be dependent on this variable. This is kind of dumb example, but this kind of shows you how to set up different variables to keep things up to date. So now we need to bind to some properties. Let's use our bind method on the view component, which you can override to do this. And here we can do any stuff we do on the view using the view object. So we can view.subscribe, or actually let's do view bind property for now. and I will give it a selector which will return Pinky Allen's game score property, and set up a handler called score changed. I got this one generated for me, and I'm going to set my score to the newly updated score. Let's see if it works. As you can see, our score gets updated as expected. Also, you cannot use the bind method itself, but bind dynamically. Let's create another button here called subscribe, or let's do bind. And yeah, I guess I have to type it in again. Bind property, Pinky Allen's game, score property, state, or score changed. The benefits of using bindings are that if you have your view model being updated backgroundly, like now we don't have any information on the screen, if we bind, we immediately get the notification about its current state. However, as for uFrame 1.406, I found this little strange thingy here. When you use bind property, what's going on backgroundly, or behind the scenes, is that it uses this view base as a storage for the binding. So here I kind of suggest, or I suppose that my binding will be managed by this view, and I also suppose that it will be destroyed along with the view. So when the view object is killed, I want my binding to be killed as well. But if we go to add binding, we can see that it actually adds binding to the bindings array, which is only used in setup bindings and in the method called remove binding, which sort of removes the binding, but this one has no usages. So that's why if I go to my Pinky Allen's GUI and on my score change, I will try to access my view and, you know, get component from this one called transform or whatever. And also I will add a new button here called destroy view, Pinky Allen's game view. So what I want to happen is that when I destroy the view, I want my bindings managed by this view to be destroyed as well. So here I use bind property, which stores the binding in the view, and I want this not to be invoked when the view is dead. But what really happens is when I start the game and bind, I kill those enemies, it's okay. When I destroy the view, you see we got no more Pinky Allen's game view. I got this null reference exception coming from my cold binding. So I'm not entirely sure if this is a bug or this is supposed to be this way, but it's kind of strange to me. On the other hand, we can use a method called subscribe. Let me change the setup a bit. I will call my two buttons subscribe and unsubscribe. I will remove the call to the view because I have shown you this little strange thing. and I don't need this anymore. And here I will use method called subscribe, which doesn't require selector but the property itself. And the cool thing about this method is what it returns is another method which allows you to unsubscribe, and I can call this one as any other method. So what we currently have is we have two buttons. I can start the game. I don't have my stuff updated. If I subscribe, I still don't have my stuff updated. But however, if I kill someone, I got my true properties of the view model here displayed. If I unsubscribe, the handler is not invoked anymore. So the good thing about subscribe and unsubscribe that you actually have a very flexible way of adjusting things in time, and also the binding is not produced. So what's going on here is that your handler that you pass here is wrapped with some object so that it can be subscribed to the native C# property defined on the model property you provide, and then it returns you another lambda method or lambda function which just unsubscribes your handler. Kinda straightforward. But the drawback of this is that if you subscribe, you don't get the up-to-date information just after you subscribe. You only get it when the property is actually changed. So in this part, we have fixed a few bugs, added some effects, played around with GUI, learned a few things about ViewComponents and how to set them up, learned a few things about bindings as well, and I guess that's it. Thanks for watching.